Well, there's a few reasons why I wanted to build this project. I wanted an easy way to measure resistors. So when I'm done with the project and I pull them out of the breadboard, I can't always see the stripes really well. So I just want to be able to touch them somewhere and get the value and know where to put them away at. I'm not saying that this is a perfect project, but it turned out pretty good. I tried copying a bunch off of YouTube. I could never get them to work correctly. So I decided to build my own with the help of the internet, AI specifically. And it seems like every time I mention the word AI, my videos get throttled. So we'll see what happens with this one. But you can see there, I can just touch it and get my measurement. Also, I look for any excuse to put wires in a box. So putting a circuit board in a box, that counts for me. And I'm not a multi-tool guy. I don't like buying a tool that does 10 different things. I like buying a tool that does one thing perfectly. And so that's why I built this just to measure resistors. Also, I get to practice making circuits and learning software. I'm not actually writing the software, Chat's writing the software, but I'm learning about software by doing these projects and then going back afterwards and reviewing it or having Chat explain it to me. So in the future, I can get better at looking at the code and knowing if something's not working, trying to find it. So that's been working out real well for me, and it's been a lot of fun. So of course I build it on a breadboard first, and I find breadboards to be nightmares. Yeah, it's easy to plug in wires to them, but man, to get a steady reading value out of some of this stuff was crazy. That's why I ended up soldering it onto a board, and that smoothed it out quite a bit. So I don't know if this is the perfect way to make this project. I just know at the end it worked the way I wanted it to. So you may have a better way. Let us know in the comments if there's something. I make a lot of mistakes in this, but it still worked in the end. So if there's something I could do better, let me know. So I hand drew out a little diagram here so I could start building it on a circuit board. And then I learned how to do easy EDA, and this is my first diagram, so it may be horrible. I don't know. It's working out for me okay, but let me know if there's something I can improve with this. So I like to use these sockets whenever I can. That way, if I do something stupid and let the smoke out of one of these components, I can replace it without having to unsolder it from the board. So that's the 4051 chip that I'm using for this, and then the other one's for the Nano. So I just kind of bent the posts over to hold it in place while I got it soldered. I'll apologize in advance for a lot of soldering footage. I tried to fast forward through it the best I can, but I still kind of wanted to show every step that I could. And I tried out this flux pin, so I'm cleaning off the board with that flux pin. Seems to work okay. Next, we're going to add the resistors. We're going to put these 4 resistors on this side of the chip. There's 8 total. Okay, so what we're doing in this part is installing these 4 resistors here. You can see the notches here, so pin 1's over there. And then I'm just soldering them across here, and then they all parallel across to here. So I just insert the resistors, then bend the wires over. So I have those bent over touching the post for the socket. And then I'll just solder those together. Then the other side of the resistor is going to go to a positive, and we'll parallel those all together later. Next, we're going to do the 4 resistors on the other side, and these aren't in a row like they are on the first side. Okay, in the next part, we're going to do the next 4 resistors on the other side. So they all go to their respective pins here, and then I just paralleled them across to here. So I'm just repeating the process on this side. So it does skip one pin. That's the pin that we're going to actually use to send signal to the Nano, and one of the clips for measuring the resistors. Then I decided I better double check that I'm putting the resistors in the correct place. So I'd already soldered the other side in, but I thought I'll just check them, make sure that they're correct. Then I'm going to connect the leads for the 9-volt battery. We'll do the switch and the LED later in the video. Okay, then we're going to do the power for the 9-volt battery. So the power is going to go through this switch. So this wire has got black and red on it. They're both positive, so it goes through the switch, out of the switch, and to that pin right there, which is VIN, the voltage in. So it's just tied across there. And then the ground just goes to the ground pin right next to it, ties in the same way. We add the switch in later and the power for the LED later. Now we're going to solder in the display wires. Then I'm going to tie in the display. So you can see most of those go down here, these pins here. So you can check the diagram to see where those are all going. They just go across there, and then after we'll tie in the power, so 5-volt, and then ground over here, which this is going to be a big ground rail right there. These are some wires I got out of a kit, so they got female on both ends, so I just cut one of the ends off. We'll strip the wires back and then solder them directly to the board. Then we're going to do some of the positive side of the 5-volt here, cleaning up some of the resistor wires. Then we're going to tie in the 3 wires that go in between the chip and the nano. We're tying in these 3 pins over to here. Check the diagram to see how where these line up at. I've been struggling a lot with trying to get wires routed like what I do on the breadboards, and so what I did on this one was I would put a mark with my flush cut cutters right over the hole and then cut the wire length to where how much I think the wire needs to stick out through the hole, depending on how far I want to bend it over. And then I strip it from that mark I made. And it worked out pretty good on this project. Next, we're going to tie in the positive and the negative for the display. We're going to tie in a bunch of the positive here, so hopefully this diagram isn't too confusing. So the 5-volt comes off of here. That's for the display. Then underneath it's going to go to here, which is going to connect all those, and then over to here to connect those. So if we look at the back side, here's the 5-volt. Jumps over to here, and then it jumps over to there. So 5-volt to the resistors. Then the jumper's there. That little one right there. That's how we're feeding the 5-volt to all the resistors. So I stripped that one a little bit long so I can bend it over, and it's going to be paralleled with the display power and the 5-volt pin. And in this part, we're going to tie in a bunch of the grounds. Then the grounds tie in right here next to this one, and I'm feeding this row here with grounds. So that's going to go that way. That's going to go over here to feed these, and then these are all connected to the grounds. So as you can see here, these are connected to the grounds here. This jumps over to here. That in the middle there is going to the ground, which is over to here. So it jumps around that way. So So this is where we're pulling our grounds off, all across here. On the breadboard project, we put a 104 capacitor between A0 and ground. So I went ahead and put it on here. I can't remember if I actually needed it, if it was reading smooth or not, but it's supposed to help smooth out those readings going to the Nano. You'll see I have to reposition it on here because I put it in the wrong spot initially. And there's a little capacitor right here. Ties in there with A0 to try to smooth out that reading, and it goes from A0 to ground. And now we're going to actually tie in all the grounds. I'm going to put the ground from the display on there and solder in all those grounds we were just talking about. This is the two wires we're going to solder in for where the resistors actually connect to for measuring. Okay, and then these two black wires here that go to those clips there. One's going to A0, so you can see here, this is a mistake I made. This one should have went here, and then the white wire should have went one hole back, and that would have turned out a lot cleaner. So that's going there. That's where we're going to measure the resistor. And the other one I have to fix. I broke off, and I need to fix that. Okay, so one goes in line with pin 3 right here. The other one goes to ground right there. So you can see the mess I made trying to fix that ground. That's where that goes. This is before that previous video when I was actually installing these. I made those other videos after it was all made, and pulling it in and out of the box, I broke off that one wire. So you'll see these get repositioned later. So this one I'm actually putting it where I should have, and then I changed it and put it in the wrong spot. It technically works, it just doesn't look great. I didn't leave in all the mistakes I made, but this is one I left in to show that I redid some of this stuff, and some of it I didn't need to redo, but it's all the process of learning. Here we're going to connect pin 3 from the chip to A0 of the Nano. Connecting A0 over here to pin 3. Okay, and that also parallels where you measure the resistor. So you measure resistor here and to ground. Okay, now we're going to prepare the box. The ring on the display face plate came off, so I was able to use that to trace out the hole that I have to cut out. So you can see it there in pencil. And I just drill a couple holes in it so I can put it on my scroll saw and cut that out. It had a couple little curve spots in the top, which I found pretty difficult to get perfect, so it's just for me. It didn't turn out great, but it's not like I'm selling it to somebody, so I would have made it look much better if I was. Then I'm just checking some marks for those copper clips that I'm using to measure the resistors. Drilling some holes, that's where the wires are going to come up through there and attach to those clips. That hole I drilled a little bit too big, but it still worked out okay. That's going to be for the LED indicator, and then that's the hole for the switch. So now I'm installing some standoffs. Eventually, when I feel comfortable, I'll actually glue those standoffs in the box. Now I'm going to tie in the power. I cut that one wire a little bit too short. I should have left it longer so it'd be easier to pull it in and out of the box. But it's still working, so that wire also needs to parallel to the LED. So that was the power in from the battery to the switch. I'm going to prep the LED here. I'm going to get the leads tinned. The LED just is an indicator light, so I know when it's on. And I'm applying some heat shrink over all those exposed connections. That's the negative side. So an LED parallels to the side of the switch that powers the Nano. So when the Nano is getting power, the LED will come on. The screen would also tell you that it's on, but unfortunately the screen went bad on me at some point. So it's nice to have that LED there to know that. Now I'm gluing in a clip for the 9-volt battery and then gluing those to the face of the box. I did get them a little bit too close together. I wish I would have spread them out a little bit, but most of the times I'm just going to be touching the resistors. So here's after it's all built. So I'm just showing, measuring with the fluke. It says 220. So this wouldn't read actually 220. It would read something else, 219. But I had it in the software, I had it adjusted so it would display what the value of the resistor is supposed to be. So you can see those were 680s and I measure it and it's a 680. So I'm just going through a bunch of different values to show you that they're all working pretty well. So you can see I'm clipping them in, but at one point I realized, hey, I made this so I could just touch them. So eventually I remember, hey, let's touch it, see? And it's still working very well. Even though I'm holding on to the resistors, I'm still getting the correct value. So the way I got it to display the value I wanted was I went and measured every resistor in my kit and wrote down the actual measurement that I got. And then I told chat to write the program so it would display, if it said 219, I had it display 220. So I did all the resistors, but it wouldn't work because 200 is too close to 220. And then I realized, well, I'm just going to use the resistor values that I use the most, 220, 330, 1K, 10K, 100K, and just had it do those values. So it may not work for every single value out there, but a lot of the popular ones that I use or that I'm using now, it will do that for. Okay, to sum all this up, the screen, I just had to reload the software and the screen started working. So the screen didn't go bad or the wiring wasn't bad or anything. I did do a lot of troubleshooting to try to figure that out, and then I thought I'll just reload the software. Screen started working. So this is not going to measure every value of resistor, but that's not what I was trying to do anyways. Just the common ones that I use. So 220, 330, 1K, 10K. It'll do a bunch of the other ones in between there too. But I had a pile of them that I did last night and it worked really well. So if I got a weird measurement, then I would pull out the meter and measure them with the meter. One of the problems is the 100 ohms will read 12K. So I have to be careful with that. When I see 12K, then I know I either got to look at the stripes closer or remeasure it with the meter. Another issue I had was the clip for the 9-volt battery. It came out the first time I pulled the battery out. And I've never had luck with epoxy on anything. I've tried sanding, I've tried cleaning, I've tried all types of different things over the years. I'm going to try to re-glue this one back in and see what happens. But if anyone has any better way to do metal to ABS, I'd like to know. Leave that in the comments. I'll leave a screen clip here of the code, and if I figure out how to link one in the description, I will. You can check the description for other things. But that's it for this one. Thanks for watching, and we'll see you next time.